Swayam Prabha. Digital India. Educated India.
Hello and welcome to today's lecture. Today we will start discussing about testing of hypothesis. Okay. So, in testing of hypothesis, as we had concluded in last class, so there are 5 components of a test of hypothesis. Okay. For a test of hypothesis, there are 5 components. One is your H naught or null hypothesis. So, your null hypothesis, say H naught is true. Okay. You have the alternate hypothesis, okay, which contradicts H naught. This is called the alternate hypothesis. You base your calculation by calculating the test statistic and something called the p value, which we will come to today. Okay. You define a rejection region, okay, and last you have your draw your conclusion, which means you either accept, you reject H naught, or you reject H naught, accept H A, or you accept H naught. Okay. So, let us see how we go about defining H naught and H A. Okay. Imagine, okay, you want to calculate what is the average daily wage of people in Mumbai. Okay. So, you want to calculate the average daily wage of workers in Mumbai, and you want to come to the conclusion whether this average daily wage is greater than national or is greater or lesser than national average. Okay. And you are given that the national average is rupees, okay, 200 per day. Okay. So, when you try to prove the alternate hypothesis, it is always easier to disprove the prove the alternate hypothesis by proving the null hypothesis is false. Okay. So, we always begin with a null hypothesis. So, the null hypothesis in this case is that, so we want to basically prove if local average is different. So, different means either it is greater than or lesser than the national average, is different than rupees 200, which is the national average. Okay. So, your null hypothesis assumes that mu is equal to mu naught is equal to 200. That means that you assume that the local average is same as the national average. Okay. And your HA, okay, HA assumes mu is not equal to mu naught. Okay. So, this is your null hypothesis and this is your alternative hypothesis. Okay. So, what you see is in this particular example, we do not discriminate whether the local average is greater than the national average or the local average is lesser than the national. We want to know whether this average is significantly different than whatever is offered nationally. Okay. You can, so this is example 1. You can have another example, let us say. So, imagine you have the number of defective products, okay, a number or fraction, let us say we make the fraction of defective products is roughly 5%, okay, by a company in a particular line. Okay. So, the company, so there is a company manager feels a slight change in procedure can drastically improve the productivity. So, by increasing productivity, I mean that the number of defective products produced will be significantly less. Okay. So, in this case, my H naught is mu is equal to 5%, or I can write P equal to 5%, and alternate hypothesis is P is less than 5%. Okay. So, here I only care whether this has drastically changed whatever is the average. Okay. So, there is a difference between this and this. So, in this case I can accept as difference so long as the local average is drastically different than 200. So, answer of 100 may be drastically different, or answer of 500 will also qualify as different. So long it is not as 180 or 190, we can say with certainty that this is drastically different. Okay. Okay. So, let us get back to the earlier example of national average versus local average. Now, let us say there was a sample. So, of 100 wage earners, okay, 100 workers, okay, gave, okay, provided x bar is equal to 210, okay, x bar is equal to 210 and S is equal to 20. Okay. So, as before, let me rewrite the H naught. H naught is mu is equal to 200, H A is mu not equal to 200. Okay. So, how do I draw a conclusion whether this statistics is drastically different and the mean which can be obtained from this statistics is different than this. Okay. So, for this we use a test statistic, okay, and we know that when your sample size is large, so n equal to 100 qualifies as reasonably large sample size, then I can write that x bar is a normal distribution, okay, with standard deviation. So, we can write this test statistic, okay, or Z I can define as x bar minus mu by sigma by S by root of n. Okay. So, this Z I can compute the value, okay, x bar is 210 minus mu is 200, okay, by S is 20 and root of 100. So, you get 10 is equal to 10 divided by, okay, 2 equal to 5. Okay. So, the test statistic Z gives me a value of 5. In other words, what this tells me is the value that I obtained, okay, the value that I obtained is 5 standard deviations away from the mean. Okay. So, the p value, okay, is taken as the probability of observing, okay, a test statistic as extreme or even more extreme than the observed value. So, this, so our p value is nothing but a probability, right. So, I can calculate the p value as per this definition. So, in the above case I had obtained z equal to 5. Okay. So, my p value then becomes, okay, p value is the probability of observing a test as extreme as or even more extreme than the observed value. So, p value is probability of z greater than 5 or probability of z less than minus 5. Okay. So, you know for 5 standard deviations away this value will be negligible. So, for all practical values p value is very close to 0. Okay. So, if you have a large z value, large test statistic, okay, or small, okay, p value would indicate that event is very unlikely if H naught is true. Okay. So, this tells me that in this case this is a very unlikely event if the average was to be 200. So, in this particular case I can say I would accept H naught, okay, I will accept H naught, okay, because this probability is very low. Okay. So, between the two cases, okay, accept or reject is based by dividing the entire possibility of test statistics into two regions. Okay. So, in the case of salary, for example, so this is your mean salary, okay, you can have either less or higher. Okay. So, you can say if it is beyond this value I would reject or rejection region. Rejection of H naught is either if this value is very far off, okay, okay, and this is the acceptance region. Okay, so this sorry. So, this in the last case this has to be I have to reject H naught, okay, since this is 5 standard deviations away from it. Okay. So, this is the acceptance region where H naught is true, this assertion is accepted, okay, versus for these 2 points you have a rejection. So, this or these values are referred to as critical values, and this test, because you have 2 zones possible, this is called a two-tailed test of hypothesis. Okay. In the other example we had discussed briefly that you have a fraction f of 5%, okay, which is, so this corresponds to H naught is true. Okay. So, you want to lower the defective pieces. Okay. So, your critical value is somewhere to the much to the left of it, okay, and this is your rejection region. Okay. This is your rejection region and this is your critical value. Okay. So, this is an example of a one-tailed test of hypothesis. Okay. Okay. So, these are the 2 possibilities. Now, we want to see how do you go about deciding on the critical value and the acceptance or rejection Okay. So, as one would expect, this depends on how much certainty we want to have in our assertion. Okay. So, let us take a sample case. Okay. So, let us take again H naught is mu equal to mu naught, okay, and we take H A is mu greater than mu naught. Okay. So, I would go about by calculating the test statistics Z given by x bar minus mu naught by S by root of n. Okay. So, if I were to draw the whole curve, okay, okay, so this is my 0, okay, since I am plotting the Z is a standard normal variable. Okay. So, I can say that if my Z is more than certain times, I can this is a probability, this is the, so let us say we call this as alpha or the significance level of rejection. Okay. So, till this zone, so in this particular case, since mu is greater than mu naught is considered, so this part of the curve does not even come into existence. But for this part of the curve, so this alpha will stipulate a critical value of Z alpha by 2. Okay. So, depending on the confidence level that we want, we can change this value of Z of alpha by 2, as we have done for our confidence intervals. Okay. So, if I draw it again, okay, if for example, I want alpha equal to 0.01, okay, alpha is nothing but this area under this curve. So, alpha is the probability, okay, this probability, and this is the area under this curve, and this is my Z of alpha by 2. So, if I choose alpha equal to 0.01, then Z of alpha by 2 becomes 2.33. So, if for the sample my Z value is greater than 2.33, then I would reject H naught. Okay. I would reject H naught and accept H of A. So, alpha is nothing but the area under the curve. Alpha is called the significance level. So, alpha is also called the significance level. Okay. So, Z of alpha by 2 is 2.33 corresponding to alpha equal to 0.01. Okay. So, similarly I can write, okay. So, if I want alpha is equal to 0.05, okay, alpha equal to 0.05, I will get a value of Z alpha by 2 of, so if this is 0.05, then Z of alpha by 2 is 1.645. Okay. Okay. So, let us take an example. Okay. So, the average weekly earnings for female social workers in the US equal to $670. So, the question is to find out, do men in the same positions have higher income? Okay. So, a random sample of n equal to 40 individuals, 40 male individuals has given the statistics of x bar equal to $725 and S equal to $102. Okay. So, you want to calculate, so test, okay, test the appropriate hypothesis, the hypothesis using alpha equal to 0.01. Okay. Okay. So, what you have been given is mu is equal to average weekly salaries, weekly income of women equal to $670. Okay. The X bar is the salary of average weekly men of 40 males. So, you have N equal to 40, S equal to 102 and X bar is 725. Okay. So, as before, okay. So, as before we want to calculate the test statistics which is given by Z. Okay. So, before doing that, let us write what is the null hypothesis. Null hypothesis is mu equal to mu naught equal to 670 and HA is mu is greater than mu naught. Okay. So, everything is based on the test statistics. So, I can find out Z equal to X bar minus mu naught by S by root of N, okay, is 725 minus of 670 by 102 by root of 40. So, the value of Z comes out to be roughly 3.41. Okay. Now, for significance level of alpha of 0.01, for significance level of alpha 0.01, I have Z alpha by 2 equal to 2.33. Okay. So, since Z is greater than 2.33, I can reject H naught, okay, and accept H A. Okay. So, there is a slight difference as again for a two-tail test. So, for a two-tail test, okay, for a two-tail test, okay, 0, okay, and for a one-tail test, okay, I can just write set of alpha. Okay. So, you can write this. So, this area is alpha for a one tail test and these two areas are alpha by 2 for the two tail test. Okay. So, this gives you, okay. So, this gives you, okay. So, for the one tail test, if I put down the values, so for alpha equal to 0.05, I have Z of alpha equal to 1.645. For alpha equal to 0.05, okay. 0.02, I get Z of alpha equal to 2.03, and for alpha equal to 0.01, I get Z of alpha equal to 2.33. Okay. So, these values for a two-tail test I refer as Z of alpha by 2. For a single test, single one-tail test, you only represent by Z of alpha. Okay. So, with that you can I conclude our lecture for today. We have introduced the concept of testing of hypothesis and we showed that you have 5 parts of a hypothesis testing. You start with the null hypothesis. You always write the null hypothesis as I have done here with an equality. So, a null hypothesis will never an unequal to sign in this signal. Okay. So, this is an example of a null hypothesis where I write mu equal to mu naught. You have an alternate hypothesis which seems which intends to negate or contradict your null hypothesis. You can write as mu not equal to mu naught, or mu greater than mu naught, or mu less than mu naught, as the case may be. Okay. And you based on the statistics or the sample size, you will probably be given the sample mean, the number of observations in the sample, and the sample standard of deviation. You will go ahead and calculate the test statistics. Okay. And once you have observed the test statistics, you will calculate either if your z value is greater than either z of alpha by 2, probability of z of alpha by 2 and probability z are less than minus z of alpha by 2, that is going to be alpha, or for the one tail test, probability of z greater than z of alpha. Okay. Then you can calculate, you will see the value of z. If z is greater than z alpha, or z is less than z alpha, you can accordingly accept your null hypothesis or reject your null hypothesis when z is greater than z alpha. With that, I conclude today's lecture, and I will continue in the next day's lecture. Thank you.